Now let's talk about the real issue that most people completely miss, and this is where things get interesting. Right finger IPv4 versus IPv6. This is the biggest hidden reason why your API might not be working. Let me explain this in a very simple way. When you whitelist your IP in Cortex Neo, you are usually adding an IPv4 address. For example, something like 124.45.67.89. This is a standard IPv4 address, but modern servers often support both IPv4 and IPv6. This is called a dual stack network. Now here is the problem. Even though you whitelist an IPv4 address, your server might actually be sending requests using IPv6, and IPv6 looks very different. It contains long hexadecimal values separated by colons. So what happens in this case? You have added the correct IPv4 address, but your server is not using it. Instead, it is sending requests using IPv6, and Cortex sees a completely different IP. Because of this mismatch, your requests are rejected, and this is why your login might still work, but your order placement fails. Now let's verify this step by step. First, go to your server, not your laptop. This is very important. Then run this command, curl4api.ipify.org. This will show your IPv4 address. Now run the second command, curl6api.ipify.org. This will show your IPv6 address. If both commands return different values, your server supports dual stack, and this is where things can go wrong. Now let's take it one step further. Cortex provides an API to check the client IP. Use that API and see what IP is actually being detected. If the IP returned is an IPv6 address, then that confirms your issue. This means your server is sending requests over IPv6, even though you whitelisted IPv4, and that is exactly why your API is failing. I will show you the exact fix to force your application to use IPv4 and solve this issue completely. Now that we understand the root cause, let's fix the issue step by step. The goal is very simple. Make sure your application uses IPv4 instead of IPv6, because in many systems today, both IPv4 and IPv6 are available, and your application may automatically choose one. But if your backend, API provider, or firewall expects IPv4, and your system sends IPv6, the request may fail. So the fix is not always about changing logic or debugging code. It is about controlling how your application resolves and uses network addresses. Let's understand how to handle this in a generic way. Most programming environments, whether it is Node.js, Python, or any backend framework, rely on DNS resolution to decide which IP version to use. By default, many systems prefer IPv6 if it is available. So even if your server has a valid IPv4, your requests might still go out using IPv6. To solve this, you need to explicitly prioritize IPv4. In Node.js, you can configure DNS resolution to prefer IPv4. In Python, you can control socket behavior or use libraries that enforce IPv4 connections. In other environments, you may need to configure your HTTP client or networking layer. The exact implementation may differ, but the idea is always the same. Force or prioritize IPv4 at the network level. Another approach is to explicitly specify the IP family in your request configuration. Many HTTP clients allow setting a parameter like family equals 4 inches or similar options. This ensures that all outgoing requests use IPv4 only. Once you make this change, restart your application, because networking configurations often do not apply to already running sessions. Now comes an important step that many developers ignore. Clear any cached sessions or tokens, because previous sessions may still be tied to older network behavior. Then create a fresh session and test again. Next, verify what IP your application is actually using. You can do this by calling a simple external API that returns your public IP. Make sure the result matches your expected IPv4 address. If everything is configured correctly, your request should now work without any mismatch issues. Let's quickly summarize the steps. Identify whether your system supports both IPv4 and IPv6. Check which IP version is being used in outgoing requests. Force or prioritize IPv4 in your application or network configuration. Restart your application. Clear old sessions or cached data. Create a new session. Verify the outgoing IP. And finally, test your request. If all these steps are followed, your system should behave consistently across environments. And here is the key takeaway. Many connectivity issues are not caused by bugs in your code. They are caused by network configuration mismatches. Once you understand how IP resolution works, these problems become much easier to solve. If you found this helpful, make sure to subscribe and share your experience.